Yes, please. Welcome back after the break. Yes. Are you with me? Hello?
Yes.
Okay, good. Now, next topic is not in the book, in fact. So please listen carefully now. Unit vector. As you see from the name, a vector, of course, it is a vector. Unit from unity. Wahda. So we are one nation, unity, we are united. So one, any vector whose magnitude is 1 is called a unit vector in any given specified direction. Okay, now how we write it, you see, for example, if you have I say you have this direction 1, 2 and 3, you have 3 magnitude. Okay, and along any direction I say, okay, I say this is in the direction positive x-axis, like I say unit vector. So I write here any vector A whose magnitude is 3. You see different notation. This is arrowheads, complete vector. This is unit vector. We read it A cap on its head. 3 is the magnitude, right? And if I write the unit vector, I can write A vector over magnitudes, right? And magnitude is A, so I can write it A vector is equal to its magnitude multiplied by the unit vector. You get the point? So here you have A is equal to 3. So A unit vector or A cap is equal to A complete vector over A. You see the difference? This is complete vector A with magnitude and direction. This is the unit vector. It has the direction but magnitude is 1. So this is the magnitude of vector A. Similarly, if you have any vector V, for example, this is V vector having any magnitude, right, in this direction, how I can write it? The unit vector V cap, V unit vector in this direction, and magnitude is 1. Okay. Now, yes, any question? Any, this is example. Okay. For example, you have 1, 2, 3, 4, 5, 6, 7. This is V vector, its magnitude is 7, for example, I say meter, right? And direction, this direction. And I use V cap unit vector. This is the vector showing the direction. Okay, and like this one, right? Now we will be using as a rule, if you have 2 dimensionals x-axis and y-axis, any vector which is along the positive x direction, we use I unit vector as a rule. For example, I have this vector with magnitude 2 in the x positive direction. I would write 2i. For example, I have a vector 2i, mean its magnitude is 2 and direction along positive x-axis, but for positive x-axis we use I. If some vector is along negative x-axis, I would use minus I, and along y-axis we use the unit vector j. Opposite to this minus y-axis we use minus j. If you have 3 dimensions x-axis, y-axis and z-axis. We use along, as a rule, keep in mind, this is as a rule. Along x-axis we use I unit vector, along y-axis we use j unit vector, along z-axis we use k unit vector as a rule. This is the basic idea, by the way. Now, before we did vector addition and subtraction, now we are going to discuss how we multiply vector with another vectors.
You recorded the class?
Sorry?
You
Sorry? Recording?
Yes.
Yes, I am recording. It will be on the Blackboard and YouTube channel also, both. Right. Now, how to multiply two vectors? When we multiply one vector with another vector, A vector and B vector multiplication, we have two types of multiplication. Right? One type of multiplication, number one by one. So this is the first one, multiplication, and we call it dot or scalar product. Why we give them this name? Because we use a dot between A vector and B vector. Can you see this dot black? Can you see it? Yes, this is dot for multiplication, okay? Dot is for this point, or the dot is for multiplication. A vector, we read it like this: A vector dot B vector multiplication is equal to AB cosine theta. You see, you don't have arrowhead on A and B, sir. These are the magnitude only, scalar. These are vectors, sir. Now, we have A vector and B vector. We join the beginning of both and we take the smaller angle between the two, theta. This is A vector, this is B vector. And this is the rule that A vector dot B vector is equal to AB cosine of theta. A scalar, or the magnitude of A vector A multiplied by the magnitude of vector B multiplied by cosine of angle between the two. Theta is the angle between two. Right. Now, we are going to use this concept for unit vectors. Right. If, for example, you have one unit vector I and the second I, the multiplication of the unit vector by itself. You see, as I told you, I unit vector is along the positive x-axis, huh? Yeah. And again, the same positive direction. What is the angle between two? 0. Theta is 0. So if theta is 0, if you use the calculator, cosine of 0 will be equal to 1. Okay. So this is how we write it here. So I dot I is equal to j dot I j, because theta is 0, so cosine 0 is 1, so all are equal to 1. Now you get the idea, sir. Now we use different I and j. You see, I is along positive x-axis and j is along positive y-axis. What is the angle between I and j? 90 degree. So, and cosine 90, if you use the calculator, cosine of 90 becomes equal 0. So you see, if you use the angle of between any two axes, if you take the wall of your room where you are sitting, and one goes in the length, this is x, other goes in the width, y-axis, and the third goes height up. If you look closely, the angle between x and y is 90, y and z is 90, z and x is 90. So cosine 90 becomes 0. This is the reason that opposite multiplication dot product becomes 0. We will be using this rule. When you have the same I dot j k k 1, different will be equal to 0. So keep in mind, we'll be using this rule. Right. This is in general, if we are using that rule what I just discussed with you, that if you have any vector, this is ax. So as I told you, any vector before we used, this is, for example, a vector, unit vector, right? For example, if you have magnitude 3 in the direction of a vector like this one, now we are using the unit vectors I, j, k along x, y, z axis. So this is a vector and this is b vector. Now if you multiply, this is the rule that a dot b vector becomes equal to, this is simple rule you can use directly. Okay, how it comes, by the way, in fact, if I take, for example, a vector dot b vector ax I plus a y j plus a z k multiply dot b x I equals, what I do, I take the first one axi and I multiply dot with this one plus same axi multiply by this plus axi multiply with this. So when you are multiplying, I dot I becomes 1, okay, it's here, remaining all 0 because j dot k dot I becomes 0. Similarly, when you take this second one ayj multiply with this bxi, so j dot I 0, j dot j becomes 1 and you get a y b y plus, finally if you take this one and multiply all, so all other 0 except k dot k1 and you get this one. So this result you can use directly. For example, if you have here 3i plus 2j minus 4k, the second one you have 0i plus 3j plus 2k. If you use this rule, ax, how much? This is ax 3 multiplied by bx, which is 0, so you have 0, plus ay multiplied by by, okay, ay 2 by 3 plus az bz, az minus 4 and bz 2, you get 5 6 minus, you get minus 2, your answer. Okay, that's it, how we do this. So again, you can use directly this rule that whenever you have a vector dot b vector, this when you are given a vector and b vector in its components, x component, y component and z component, like this is x component of A, this is y component, and this is z component. Similarly for the B vector. Okay, any question?
Teacher, the question will give us all the AX and beta A2.
Yes, yes, yes. Right. Right. Now next is the second type of multiplication. We call it cross or vector. You see, the first one we called it the dot product or scalar. Dot because we put dot in between two vectors multiplication, and scalar we call it because the answer you get is scalar, only the magnitude. Like you have magnitude -2 here, the answer of this question. Now we call it the second type of multiplication is the cross or vector product. We call it vector product because the answer is, your resultant is a vector, and we call it cross because we use for multiplication cross in between. You see here, A vector cross B vector. Before you have cosine, now as a rule you have A vector A vector cross B vector is equal to magnitude of A multiplied by the magnitude of vector B multiplied by the sine of angle between the two, and this is n unit. That's why you have right side a vector. N unit vector is the unit vector showing the direction of the final resultant answer. Okay, as you see here, n is a unit vector perpendicular to both plane. If you have, for example, this A vector, this V vector. So if you move your finger from A vector to B, right, upward direction with the right hand thumb rule, you see this one, if you move your thumb from the A vector to B, thumb indicates in the upward direction. So the C vector, resultant vector, or n unit vector, it has direction upward. Okay, so by the right hand rule we call it, this is the right hand rule. Okay, so whenever you have cross product or vector, you have vector answer and you use cross in between. Now if you have B cross A, B, since it is a vector having the direction also, so A cross B cannot be equal to B cross A. So B cross A have the direction down. You see, A cross B has direction up and B cross A direction down. Okay, this is different. Right hand rule. Move your forefingers of your right hand from the first vector to the second. In the first case, first vector was A. So you move your fingers from A to B. So upward is the direction, right hand rule. But here, if you have B cross A, so first vector is B. So move your forefingers from the B to A. So the resultant direction is down. This is the difference. Okay, so B cross A is not equal to A cross B, but it is equal to minus A cross B. Means magnitude of both same but direction different only. A cross B is up and B cross A is down. Now, order is really very important. This is what I already wrote for you. You see, before we did I cross I and j cross j, k cross k was equal to 1 and the remaining opposite was 0. Now opposite have something and the same will be having 0. Right? Now the cyclic way of remembering this one is like this one. We call it the cyclic way. Okay? اتجاه واحد, one way. Now, how to remember I cross j? For example, if you have this I, you have this j, you have this k. Now, if you go in a cyclic way, one way, اتجاه واحد, I, next is j, I cross j, I cross j, equal I cross j. If you go in the same way, one way, the third one is k. It's equal to k. You get it? Similarly, if you have j cross k, j here, then next is k, equal I, this one. The third one, k and I. You start from k, go in the same one way, cross I, equal to third one, which is j. You see, again I cross j is equal to k, but if you start j cross I, so this is j, I is reverse, so you have to go in the opposite direction, mukhalfa, minus. So j, you go back opposite way in the wrong direction, j cross I will be equal to k but negative. You see here, this one, okay, this one minus k. If you did reverse the direction, all these directions, you will be getting minus with the unit vectors. Okay, whereas with the same one, I cross I, j cross k cross k is equal to 0. Why? Because this is for example I, again multiplying it with itself, and the rule is a cross b is equal to a b sine theta and unit vector. So you have sine theta, and here you have I cross I, angle is 0 degree, j cross j, angle is 0, same direction, k cross k, angle is 0. If you use the calculator, sine 0 will give you 0. That's the reason you have all these things. So we'll be using these in the coming topics. Now, the similar way we did before, that if you have a vector in the form of component and unit vectors, b vector, right, it can ax, ay, az, any number. Similarly, bx, by, bz, any numbers, right, plus or negative. Now, how we do it, you might have done in your math course. Determinants are the matrices. We do it a cross b, the magnitude. Now I unit vector, j unit vector, k unit vector. So because I j k. Now under the I write for a ax, and under the I for bx I write bx. So this is ax plus ay plus az. Similarly for b, I write here a I unit vector, this one. I forget this column and this row. You're left with these four. So multiply these two, ay bz, minus multiply these two, minus j unit vector here. Okay, and I forget this column and this row, so you multiply by ax bz minus multiply with the other two. Similarly, the last one plus k, I forget this column where k is involved and this row also, so you have these two multiply minus these two multiply. This is the rule you have to remember directly, or you can start from the beginning so that you don't make any mistake. Okay, So that's it. Okay, right. I think we keep it up to here. If you have any question, we can go for. Any question, please?
Teacher,
Yeah.
this is for explain how the arrows like this or what?
Yes, this is explanation, but you can use the final rule as you see here. For example, if you have, I say, okay, for example, here you have 3, here you have -2, here you have 0. Similarly, here you have -2, for example, here you have 1, here you have 3, for example, right? -2i plus j plus 3k. Here you have
Like
3.
math, yeah.
Huh?
Like math.
Exactly. So you simply substitute these values over here and you will get final answer, right? For example, ay is -2 multiplied by bz. Bz is 3 minus az. Az is 0, so it will be 0. Okay, so this is I, and minus ax, how much? 3 multiplied by bz, 3 minus az bx. Az 0, so it will be 0, of course. So this is j, and then you have ax, for example, 3, by you have 1 minus ay bx. Ay is -2 and bx is -2 and then k. So finally you will be getting, for example, -6i and -9j and plus and minus. So 3 minus 4. So this will be k only, plus, okay, minus k, like this one. Yes, please.
Teacher,
Yeah.
in the exam, we going to letter or
Sorry.
the exam?
No.
We use the letters or the number?
No, it will be given the numbers. You use simple rule and it will be given you numbers. For example, these number, like I'm giving you the example, it will be a vector is equal to 3i minus 2j plus 0k, for example. B vector is equal to -2i plus 1j plus 3k, for example. Okay, so you take numbers and you solve it. Okay, any other question, please? There is noise, I cannot hear you.
Teacher, the calculator is allowed in the exam or? Teacher?
Yes, please.
Can we use the calculator in the exam?
100% yes.